Okay, now when we are revising heat energy, we need to be clear regarding what are some terms like boiling point, freezing point, melting point, and I'm here to revise with you today. Hi, I'm Mr. Long and I'm a science teacher today. Now let's take a look at this question. Now, the table below shows the freezing points and boiling points of three unknown substances, P, Q, and R. Right, so P, Q, and R are there, and let's talk about the freezing point here of P is at 40 degrees Celsius. The boiling point is at 95 degrees Celsius. Q's freezing point is at 32 degrees Celsius. Boiling point is at 120 degrees Celsius. And R's freezing point is at 26, and freezing point is at 80 degrees Celsius. And we're asked to find out which of these substances or substance is or are liquid at 85 degrees Celsius. So to do this, it's good that we remember these three boxes that we have done and learned before. Alright? And be very familiar with this. Now there are three states of matter. What are these three states of matter? Very good. Solid, followed by liquid, and gas. Okay? Now the only substance you learned so far that can actually change these states is actually water. So when water is in a solid state, we call it ice. And when water is in the liquid state, we call it water. And water is in a gaseous state, you call it water vapor. So how do these change in states occur? Well, it always involves, and I repeat again, it always involves either a gain in heat or loss in heat. I repeat, it always involves either a gain in heat or loss in heat. So for solid to become liquid, it must be gaining heat from its surroundings. So gain heat. And when water needs to become water vapor, when water evaporates to become water vapor. So the P4 wouldn't learn this term evaporate yet, okay? But the P5s would have. So when water becomes water vapor, it needs to also gain heat. Just like a puddle of water that is there on the floor after a heavy rain will disappear after a few hours because of the sun. Alright? And when gases lose heat, it becomes liquid. And we put a glass of water into the freezer, and the glass of water loses heat to the surroundings, which is a very cold freezer. It becomes a solid block of ice. Now, just a bit more to fill out this table, this diagram. Now, there's certain things to talk about earlier on, right? Freezing points, boiling points, and all that. So this process from solid becoming liquid is known as melting. And this melting happens at a specific temperature that is called a melting point. So melting point, I put out MP, right, happens, and this melting point will be different for different substances. And from liquid to becomes a gas, it can go through two processes. One is called evaporation, and evaporation can happen at any temperature between the freezing point and the melting point. And if the amount of heat from the surrounding is so high, it can actually cause this liquid, which may be water or may not be water, to become a gas at a temperature known as a boiling point. Alright, so that's when it's boiling. Now for the P4s, your main thing you need to learn is regarding from solid to liquid to gas. It involves a gain in heat here and a loss in heat here. These terms such as a melting point, evaporation, boiling point is not necessary until your P5s. So for the P5s, please take note of these terms. And from a gas to become a liquid, it's like your water vapor in the air becoming clouds. We're going to lose heat, and this process is known as this process is when it evaporates to become water vapor. When it loses heat, this part is what we call condensation. It's like when you blow your hot breath onto your lenses of your glasses or onto the mirror, it forms these little tiny water droplets. And then from water to lose further heat to become this, it happens at this temperature known as the freezing point, or this is also known as the freezing. Now that we've gone through the revision of this, let's take a look at this question again. So it says that P has a certain freezing point and melting point. Now for Mr. Long, I like to do this using this particular working. Alright, so I like to use a straight line to represent P in this way, like this. Okay, so it says that the freezing point of P is at 40 degrees Celsius. So that means that any temperature below this, must be a solid. And when it gains heat, it starts to melt here. The freezing point, by the way, is the same as the melting point. Freezing point is the same as the melting point. So if here, it will be a liquid. Once it melted, it goes into a liquid. And then it starts to boil at 95 degrees Celsius, so this will be my 95. So this part here will be gas. And this whole portion here, it will be liquid. Now let's take a look at Q. Okay, Q is at 32 degrees. It's a solid at 32 degrees Celsius. So this is 40, so 32 a bit lower. 32 is here, so this part it is a solid. And it boils at 120 degrees Celsius. So up here above 95 is 120. So here will be gas. So this whole part will be liquid. Okay. And last part will be R at 28 and at 80. So where will I put 28? 28 is below 32. Alright. So 28 is here. Is R. So this part here is solid. This part is liquid. And then at 80 degrees Celsius, it is the boiling point. So 80 degrees will be below 95. So 80 will be somewhere here. Okay, notice how I use this and I put them side by side for comparison. Here will be gas. Now the question asks us, at 85 degrees, which of these will be liquids at 85? So I just look for where is 85. 85 must be above 80 and 85 is below 95. So 85 is somewhere here. Okay, let's take a look which one is a liquid. So P is a liquid. You see, it's within this range. This line is within this range. So P is a liquid at this temperature. How about Q? Q is also a liquid at this temperature. Alright, so these two are down. How about R? Okay, R is a liquid only when it's under 80 and above 28. At this temperature here, however, it is a gas. So this is not a liquid at 85 degrees Celsius. So therefore the answer is P and Q. The answer here will be number 3, P and Q. Now let's try one more question of a similar type. Now, of course, I'd like you to try these questions before you actually look at my solution. So please pause the video, look at the question, try it out first. Substance X freezes at 63 degrees Celsius and boils at 759 degrees Celsius. This is definitely not water, but it doesn't matter. So long as we know this diagram, we can solve all of such questions, regardless of whether we have come across it before. Now, which one of these show the correct state of substance X at 70 degrees Celsius and at 500 degrees Celsius? State refers always to solid, liquid, and gas. Alright, so let's take a quick look at the solution. For those, I hope that you have tried it first. You pause the video and try it before you carry on and look at the solution. Now, remember the working, I will have, well, I need to know this is substance X. Let's say that substance X. So X, 63 degrees Celsius is where it freezes. 63, so this part will be solid, this part is liquid, and 759 degrees Celsius will be the boiling point, so this part definitely gas. So the answer to find out, alright, at 70 degrees Celsius, what is the state of substance X? So 70 is here. So at 70 degrees Celsius, it is a liquid. Make sense to you? Below 63 is solid. Above 63 and underneath and below 759 will be a liquid. How about at 500 degrees Celsius? 500 is here, right? 500 degrees Celsius. It is still within this range of liquid, see? So it's still a liquid. So therefore, the answer here must be 4. I hope you got this correct, right? Now the last one, I'll leave it to you to try on your own. And when you have tried it, you can actually text me, put the answer in the comments below in the YouTube, or you can also ask me when Skrill opens. Alright, I'll look forward to your comments and any questions that you may have. Have a good time revising and learning. Have a nice day. And I'll see you again soon.